Okay, let's just jump right in because what we're about to talk about, it could completely change how you think about your own mind. We're diving into the incredible work of Dr. Laura Boyd, a top brain researcher. And get this, by the time we're done here, your brain literally won't be the same.
So let me ask you something. Have you ever thought to yourself, oh, I'm just not a math person? Or maybe I'm way too old to learn a new language. You know that feeling? Well, it comes from this really old, really sticky idea about how our brains work.
For decades, the scientific consensus was, well, it was pretty grim. The idea was that once you hit puberty, your brain was basically done, cooked. The only changes you could expect were, bad ones, losing brain cells as you got older, or damage from something awful like a stroke.
Well, as it turns out, that couldn't be farther from the truth. Thanks to researchers like Dr. Boyd and the whole field of modern neuroscience, that old belief has been completely, totally debunked. The truth is, your brain is constantly changing. It's dynamic, it's alive, and it keeps changing for your entire life.
And this amazing ability has a name: neuroplasticity. And listen, this isn't some, vague feel-good concept. It is a physical reality. Every single time you learn a new fact, every time you practice a skill, even just having a new thought, you are physically changing the structure and the function of your brain. How cool is that?
So you might be wondering, how does this actually work, right? How does an experience become, well, a physical part of you? It turns out learning isn't just one thing. There are actually three main ways your brain changes to make it all happen.
Yeah, your brain has this whole toolkit for change. It uses chemicals, it changes its physical structure, and it adjusts its function. You can kind of think of them as working on different timelines. The chemical changes, super fast. The structural changes, those take a little more time to build, like construction. And the functional changes, that's all about making the paths you use more efficient, like paving a road. They all work together, but each one has its own special job in the learning process.
Okay, this slide. This explains something we've all felt, right? Imagine you're learning to play a song on the piano for the first time. During that first practice, you start to get better and better, and you have that, aha, I've got it moment. That's a chemical change. It's a quick, short-term boost in the signals between your neurons. But then what happens? You come back the next day, and it's gone. Poof. Why? Well, that chemical boost didn't stick around long enough to create a lasting, structural change, a real, physical rewiring of the connections. That structural change, that's long-term memory.
And this isn't just a theory. We can actually see these structural changes in people. For example, people who read Braille have physically larger sensory areas in their brains for their hands. Makes sense, right? If you're right-handed, the motor region on the left side of your brain that controls that hand is bigger. And this last one is just brilliant. London taxi drivers who have to memorize this insane map of the city called the Knowledge, they have larger brain regions dedicated to spatial memory. They literally built bigger brain parts just by studying.
And then there's the third type of change, functional. The best way to think about this is use it and it gets easier to use. It's like paving a dirt path. The more you travel down a certain brain pathway, the more efficient and excitable it becomes. Your brain literally starts shifting its resources around to make it easier and faster to fire up that network again. Whole networks of brain activity remap themselves based on what you do over and over.
Okay, so if our brains are these incredible shape-shifting machines, that brings up a really important question, doesn't it? Why is learning still so hard sometimes? Why do we struggle? And on a more serious note, why is recovering from brain damage, like a stroke, so incredibly difficult?
Well, to really get this paradox, we have to look at a pretty harsh reality. Thanks to modern medicine, a stroke is no longer the #1 cause of death, but it's earned a different, devastating title. It is the #1 leading cause of long-term disability in the entire world.
And here's the tough part. We've gotten so much better at saving people's lives after a stroke, which is amazing, but we've largely failed at helping them truly recover. The quality of life for so many survivors has actually gone down. This isn't just a medical issue, it's a huge societal problem, and it really forces us to look at the challenges and the limits of neuroplasticity. But here's the silver lining. Studying the brains of stroke survivors has taught us some really profound lessons. Lessons that apply to every single one of us, whether we're recovering from an injury or just, trying to learn guitar. This research has uncovered 2 fundamental rules that seem to govern how all our brains change.
Okay, lesson number 1. And this is probably the most important thing to take away from all of this. There is no magic pill for learning. There's no drug you can take that's just going to make your brain more plastic. The single best,
most powerful driver of change in your brain is your behavior. Simple as that. You have to do the work.
And this is so critical. That feeling of struggle when you're practicing something new, that is not a sign of failure. In fact, Dr. Boyd's research shows that the more difficulty you experience during practice, the greater the structural change in your brain. That struggle, that's literally the feeling of your brain building itself. It's a good thing.
But we have to be really mindful here, because plasticity, well, it's a double-edged sword. It works both ways. On the one hand, yes, it's amazing. It helps you learn a new skill or recover from an injury. That's positive plasticity. But it can also be negative. It's the reason you can forget something you used to know. It's the mechanism behind addiction. It can even lock in patterns that lead to chronic pain. Your brain just learns what you tell it to learn, good or bad.
Now, for the second big lesson we've learned, there is no one-size-fits-all approach to learning. You know that popular idea about needing 10,000 hours to master a skill? Well, it's just not that simple. The truth is, because every single one of our brains is uniquely wired, what works best for me to learn something might be completely different from what works best for you.
So, all of this brings us to what I think is the most empowering part of this whole story. Understanding neuroplasticity isn't just a cool piece of science trivia, it is a call to action. It means you are the architect of your own brain.
Just think about that for a second. Everything you do, every action you take, every skill you practice, every single thought you have.
And just as important, everything you don't do. Every bad habit you let slide, every skill you put off practicing.
It's all changing your brain, actively shaping the physical reality of your mind for better or for worse. You are constantly sculpting the very organ that you use to see and experience the world.
So what can you do with this information, starting today? Well, it means you have to become a scientist of your own learning. Start paying attention to how you learn best. Make a conscious choice to repeat the behaviors that are good for your brain and really work to break the habits that aren't. And most of all, practice. You've got to do the work that your unique brain requires to build the skills you want to have.
At the end of the day, all this science of neuroplasticity leaves us with one profound and very personal question. Knowing that you are the builder, what kind of brain are you going to build today?